Hi everyone. So this is my first experiment for Physics 2212, and this one's on charge tapes. I'm actually doing this on my phone because I have no clue how else to do it, so bear with me, it's gonna be a little funky. Okay, so an intro to the experiment. So basically we wanted to become familiar with electric charge using some household objects and making estimates and assumptions, because essentially you have to do that a lot in many fields of science. So the purpose of this experiment is to determine the sign and excess of the charge on clear tape. Some of our main results is that I got 2.916 e to the 10 excess charge on tape B. So really focusing on the models here that we use. We use a two-charge model of electric charge. Also, we talked about point charges, and we'll talk about line charges as well, understand the effect of the gravitational force and electric force, and excess electrons. So our system, of course, is with these two charged U-tapes. The surroundings is going to be the world around the tape, including the air, and some initial conditions. This is going to be the length of mass of tapes and the handles that they have on them. Okay, so the experiment. So going through the procedures and observations, we have our base tape, U-tapes, and neutral objects. So length of the base tape and the U-tape were both 20 centimeters, or in more scientifically friendly words, 0.2 meters. Mass of both tapes is 0.001 kilograms. And the U-tapes, which I created here, so basically what I had to do is I had to put down just a base tape. It's just like my workspace. And then I created U-tapes, and the U-tapes are actually just, you fold over one end and you make it into a handle. You do two of those, and you set one on the base tape, the other one on top of it, and you rip the top one off really quickly, and there's a transfer of electrons right there. So what I found out per my observations, the U-tapes are attracted to both neutral objects and hand, but they actually repel each other because they're negatively charged. So right here, for the last part of my experiment, I had to actually recreate figure 4 right here, and I had to figure out what the distance was between these two U-tapes before one of them starts to float. Right here, I actually created a free body diagram. We know the net Y component of the force in tape B is actually going to be 0. We have the gravitational force, and then we have the electric force. Gravitational force is always down. And in order to calculate that gravitational force, we have to have the mass of the tape, which thankfully I already calculated earlier. So to find the amount of charge on one U-tape, calculated the gravitational force, got it into units of newtons. The separation distance at which tape B floats, I measured this, it's 0.01 meters, and I calculated the charge on tape B, and finally I was able to find these excess electrons on tape B. So yeah, pretty simple. This is actually the charge of an electron right here. So pretty simple, oops, sorry about that, simple calculations. Other experiment, calculations I need to do. The number and ratio of atoms. Number of atoms on the sticky side of tape is 4e17 atoms. Ratio number of electrons, number of atoms in sticky surface, 7.29 e to the negative 8 electrons to one atom. So pretty small. Assumption, it's an evenly displaced charge, and each type is the same charge. So going through the code for my single point charge model, pretty simple here. If you can just want to look at that for a second, also the link there. Charge of my particle was, it's actually negative. Of course, because it is a negatively charged piece of tape. And as you see right here, this is the charge. Okay. Continuing on, when I use my line of charges model, this is my coding. And actually, the charge of my piece of tape was a little smaller. It was about -3 e to the -9. And then this is just some other data that I got, and that's my line of charges. Okay, yep, this is my other rest of my data as well. There's the link. So what assumptions I had to make for these models. So each U-tape has the same net charge and treated each type as if all of its charge were located at a single point in the center of the tape. So discussion, some final questions. So if the electrons were negatively charged and protons are positively charged, what if the signs of the charges were reversed? Meaning if electrons were positive and protons were negative? What would change about the observations you made with your tapes and other charged objects? So the tapes would actually be positively charged. So of course they would still be attracted to neutral objects. Yeah. So also the second question here. So the differences in the values for Q are going to be different, and this is because we're using different models. The value that's more likely to be closer to the real value in Y is going to be this line charge. It makes sense though, because in real life, of course, things are not actually represented by a single point. They're represented by a line of charges, because it's not one point in its space, it's multiple points. So thank you.